To access the standard, you can just Google it or you can click on the link that I've attached below. Most of the information begins here in section 3, and in section 3.1 it goes over some basic definitions. As a quick review, standard mode is 100 kilohertz, fast mode is 400 kilohertz, and fast mode plus is 1 meg. Over here we're reviewing some very basic information, 2 wires, we have serial data, serial clock, an example of some different devices, right? We have an LCD driver, or maybe it's only a receiver. We have a memory device where we can receive and transmit data. And then here we have our definitions in table 2. As we can see here, a transmitter is the device which sends the data to the bus. The receiver is the device which receives data from the bus. The controller is another name for the master, which is the device which initiates a transfer, generates clock signals, and terminates a transfer. The target, also known as the slave, is a device addressed by a controller. As we know in the I2C standard, there is multi-controller or multi-master functionality that's available. Arbitration is a procedure that when there's 2 masters on the bus and both of them are trying to get control of it at the same time, it decides who wins. And of course there's synchronization, which is a procedure to synchronize the clock signals of 2 or more devices. The next thing we're going to look at are the data and clock logic levels, right? And so specifically is what constitutes a low 0 and what constitutes a high as 1. The standard we're going to look at is called the 30-70 rule, and what this means is that 30% of VDD and below is going to be considered low, and 70% of VDD and above is going to be considered a high or a logic 1. And so as we have our signal here, let's say that VDD is 1 volt. We know that 0.7 volts and above, that's considered a high or a logic 1. And we know that 0.3 volts and below is considered a low or a 0. And so when we're sampling on the bus, if we see anything below 0.3 volts, we know that's a low, and anything above 0.7 volts is a high. Now this may seem very obvious and this may not make a lot of sense, but this is very useful when signal quality is degraded. And so if we have some noise here on the bus, which obviously points out a signal integrity issue, but if it was there, this rule is helpful, right? So let's pretend we have a signal like this that has a lot of noise on it. And so, we can pretend this is 30 here. If 30% and below of the signal is considered a logical 0 or a low, this noise doesn't affect it. And if 70% and above is considered a logical high or a 1, this noise does not affect it. And so the 30-70 rule makes it pretty simple to decide what's a high and what's a low. The next section we're going to look at is called data validity, and this is deciding when data on the bus needs to be stable. As you can see here, as the clock is rising to 1 and dropping back down to 0, the data on the line must be stable, right? So as we see the clock rise, as we see it maintain a 1, and as we see it drop, this data here should not change. Now when that clock is low, the change of data is allowed, and so that's why we can see that change here. And so the instance of an illegal situation would be if data changed when this clock was high, or if it was rising, or before it was dropping. So very quick, the important thing to know is that the data on the data line can only change when the clock is low, as the clock is rising, as the clock is a 1, and as the clock is dropping, that data must remain stable and cannot change. Alright, so we've seen this one before. If you've seen the previous video, we know what start and stop conditions are. As the clock is high, and if data is dropping, that's considered a start condition. As the clock is high, and as data is rising, that's considered a stop condition, right? This is very important. Sink it into your head, whatever you need to do, rewatch this. As data is dropping while the clock is high, as data is rising, as the clock is high, that's stop condition and start condition. Alright, that's it for this video. I want to keep it short and sweet, going a few sections at a time. so you don't get bored, you don't lose interest, and feel free to rewatch these videos and to write everything down and to check the standard. Thanks.